Solve sine x equals 0.75 for the interval of 0 degrees less or equal to x less or equal to 720 degrees. That means we're looking for the value of x between these boundaries, 0 degrees and 720 degrees, that will equal to 0.75 if we plug x into here. So if we put x in here, we do sine of x, we should get 0.75, and we need to find those values here. So the best way to start is to say, well, sine of x equals 0.75. But we know what sine is. Sine of an angle x is actually opposite over hypotenuse. And if we have a right angle triangle like that, and that is x, so that will be the opposite of x. And the hypotenuse is the longest side of a triangle, right angle triangle. And this bit here will be the adjacent. So in order to find x, we write sine of x is 0.75 over 1. That's what that meant. And that meant that the opposite is 0.75 and the hypotenuse is equal to 1. That's opposite over hypotenuse. So we can then find x. X will be equal to, if we divide both sides of this equation by sine, so I get sine over sine, we cancel sine. Then we get x equals 1 over sine. If you're dividing something by something, that meant you're multiplying by 1 over something. So because I'm dividing by sine, that meant I'm multiplying by 1 over sine. So it's 1 over sine times 0.75. So what that meant is x will become, well, in indices, 1 over sine is sine to power minus 1, 0.75. So that's indices relation to 1 over is, it will become sine to power minus 1. If I have 1 over y, it will become y to power minus 1. Now, we can plug that value in to find the value of x, the first value of x. So the first value of x will be, turn on the calculator by pressing power on. You do shift sine, and then you get the inverse sine, which is sine to power minus 1. And then you put 0.75, close the bracket. So the value here is x equals 48.6 degrees to 1 decimal place. So that's the first value of x. Now we can find the rest of the values of x that fit into that boundary condition. In order to find the rest of the x value, I've decided to draw a unit circle. If I draw a unit circle and I take my point from the center of this circle to that point over there, and I just kind of roughly draw that line, and I've extended it to this side here. And the same line could be extended to there just to see the height, to keep the distance. It's basically a rough estimate. Okay, so it's not perfect, it's just a rough estimate. And what I've done here is that I've created the angle x. And so I've created the angle x. So this angle here is angle x. And the radius is 1 because that's what the hypotenuse is. The radius is 1. So the coordinate here is just x and y. So what I meant is if I trace this line down like that, this height here from there to there, it's my y, and this is the angle x. So you can see sine is opposite over hypotenuse, and r is 1 because this length is 1. So what I meant is that my sine x is always equal to y. So the y value that I've got is 0.75. So in this case, this height here is not 1, but 0.75. When it gets to there, that'll be 1. So that's 0.75. But I'm looking for positive 1. So on this side here, this is positive 0.75. Likewise, on this side also is positive 0.75. So if I trace that line down there, again, this is another y here, and that y is also 0.75. So there are two positive values of y. But then if I extend this line down, I'll get a negative value of y. Likewise here too, I'll get a negative values of y. Because this is a sine, so we always have 4 quadrants for sine. So this is a negative values of y because it's below 0, and that will be minus 0.75. Likewise, this is a negative values of y, minus 0.75. So what am I interested in? I'm interested in these 2 points here. This point here and that point, because I'm very interested in 0.75, positive, not negative. So what is this angle here? This angle is 48.6 degrees, right? And what about that angle? Well, this angle is also 48.6. So I have to take 48.6 from 180. I'll get 131.4 degrees. So these two angles are the angles I'm interested in. And those are the angles that will give me between 0 degrees, because we measure the angles in trigonometry anti-clockwise. So that means we go in the opposite direction to clock. So anti-clockwise, and I've gone from 0 degree now to 360. Of course, we can find this angle, but we're not interested in this angle. And we're not interested in that angle. We're only interested in that and that, because these are negative y, which means sine x is negative here, sine x is negative here. We don't want that. We want the positive value of sine x. Right, so, but I need to find the degrees from 0 degrees to 2720 degrees. I have found it from 0 to 48.6 and then 131.4 degrees. And if I go all again, and then they need to add, go all again, so I need to add all this value here to get back to there. So the first angle for x is 48.6 degrees, comma, and then the second angle is 131.4 degrees. The next angle is, I need to add 48 to 131, 48.6. Then I need to add 180 plus another 48. So if I get a calculator to just see what we're talking about here. So I need 48.6 plus 180 plus 48.6, and then I need to add that to 131.4 degrees. So that's plus 131.4 degrees, and that should give us 408.6 degrees. So the next value we need is 408.6 degrees. That meant we've gone not just there, now we've gone from there all the way. So that's 48.6 here, 180 there, another 48.6. We add it on to there to get back to there. So that's 408.6 degrees. And then I need to then find the second one here, because I need to go around twice, right? Because I need to go from now 360 degrees to 720 degrees. So the next one will be, I need to add the difference here to get to this point second time. And the difference here, if this is 48.6 and that's 48.6, difference here will be 81. Let's work it out. It's 180. So let's put it there. 180 minus 48.6 minus 48.6, that will be 82.8 degrees. So that is 82.8 degrees. So I need to add 82.8 degrees to 408.6. So let's do that. So we plus 408.6. That will be 491.4 degrees. So that's 491.4 degrees. And those are the angles that we're looking for. Another way to solve this is basically to sketch the curve of sine. And we know what sine looks like. So sine start from 0 all the way to an amplitude and then back to 0 again, negative amplitude and back to 0 again. So this is 0 degrees, this is 180 degrees because that's pi. This one here is 90 degrees and that's pi over 2. And then this one here is 270 degrees and this one here is 270 degrees, which is 3 pi over 2, and this is 2 pi, 360 degrees, and that's 2 pi. Now, so we got 48.8 degrees, 48.6 degrees will be here. So if we trace it up here, the height here is 1 because it's a unit circle, so that's 1. So this height here will be 7, this height here is 0.75. So that's the height there is 0.75. That's what this is telling us. And if we trace it there, you can see that's the second one here. But what's that angle is? So that angle is 48.6 degrees. And this angle will then be, that angle will be 131.4 degrees. How did I find it? Because if this is 48.6, the angle here, that angle too will be 180 minus 48.6, so that's 131 degrees, 131.4 degrees. And then another cycle begins from 360 back to 720 here. So if you stretch that line there, you can see this angle here is now, because this is 360 and then that's 408.6 degrees, and this angle here is now 491.4 degrees. So that's another way to find it, using sine curve or sine function to find the angles. Either use that method. This method is called the cast method. So that's called cast because that meant cos, A stands for all, S stands for sine, and T stands for tan. So with the cast method, you can see the way it works is sine is the y value, right? So y is positive, so sine is positive here. And cos is the x value, So x value is positive as well. So cos is positive. And tan is sine over cos. So therefore tan is also positive. Because if you're writing tan of an angle, tan of x is sine of x over cos of x. So sine plus over plus is positive. So tan, so all is positive here. So that's why all is positive. So that's what the A stands for, all positive. And here the y value is positive, so sine is positive. So let's use a different pen. So sine is positive. And here is the x value. So that's 0, that's negative. So cos is negative. And tan is basically sine over cos. Positive over negative, tan is negative. Y is negative here. So sine is negative because this is negative y. And here is negative x. So cos is negative. And tan, if you divide sine over cos, you get positive. So tan is positive. So that's tan here. Tan is positive there. This is and then the fourth quadrant, because that's the first quadrant, second quadrant, third quadrant, and fourth quadrant. So here, y is negative, so that means sine is negative. Here, x is positive, so cos is positive. And tan will be negative over positive will be negative. And we call that process cast method. So that's cast method. C stands for cos, A stands for all, sine is S stands for sine, and T stands for tan. Using a unit circle, we can work out the values that we need when given a specific boundary. So for this value, the answer we're looking for is this one here. So just to remind you, from that value here is between 0 degrees less or equal to x less or equal to 360 degrees. This value here is between 360 degrees less or equal to x less or equal to 720 degrees. Altogether, if you look at all the values altogether, so that will be between, altogether will be between 0 degrees less or equal to x less or equal to 720 degrees.